The Big Bang, what really happened at our universe's birth? It took quite a bit more than 7 days to create the universe as we know it today. Our universe was born about 13.7 billion years ago in a massive expansion that blew space up like a gigantic balloon. That, in a nutshell, is the Big Bang theory, which virtually all cosmologists and theoretical physicists endorse. The evidence supporting the idea is extensive and convincing. We know, for example, that the universe is still expanding even now, at an ever-accelerating rate. Scientists have also discovered a predicted thermal imprint of the Big Bang, the universe pervading cosmic microwave background radiation. And we don't see any objects obviously older than 13.7 billion years, suggesting that our universe came into being around that time. All of these things put the Big Bang on an extremely solid foundation, said astrophysicist Alex Filippenko of the University of California, Berkeley. The Big Bang is an enormously successful theory. So what does this theory teach us? What really happened at the birth of our universe, and how did it take the shape we observe today? The beginning. Traditional Big Bang theory posits that our universe began with a singularity, a point of infinite density and temperature whose nature is difficult for our minds to grasp. However, this may not accurately reflect reality, researchers say, because the singularity idea is based on Einstein's theory of general relativity. The problem is, there's no reason whatsoever to believe general relativity in that regime, said Sean Carroll, a theoretical physicist at Caltech. It's going to be wrong, because it doesn't take into account quantum mechanics. And quantum mechanics is certainly going to be important once you get to that place in the history of the universe. So the very beginning of the universe remains pretty murky. Scientists think they can pick the story up at about 10 to the minus 36 seconds, 1/1,000,000,000 of a trillionth of a trillionth of a second, after the Big Bang. At that point, they believe, the universe underwent an extremely brief and dramatic period of inflation, expanding faster than the speed of light. It doubled in size perhaps 100 times or more, all within the span of a few tiny fractions of a second. Inflation may seem to violate the theory of special relativity, but that's not the case, scientists say. Special relativity holds that no information or matter can be carried between 2 points in space faster than the speed of light. But inflation was an expansion of space itself. Inflation was the bang of the Big Bang, Filippenko told Space.com. Before inflation, there was just a little bit of stuff, quite possibly, expanding just a little bit. We needed something like inflation to make the universe big. This rapidly expanding universe was pretty much empty of matter, but it harbored huge amounts of dark energy, the theory goes. Dark energy is the mysterious force that scientists think is driving the universe's current accelerating expansion. During inflation, dark energy made the universe smooth out and accelerate. But it didn't stick around for long. It was just temporary dark energy, Carroll told Space.com. It converted into ordinary matter and radiation through a process called reheating. The universe went from being cold during inflation to being hot again when all the dark energy went away. Scientists don't know what might have spurred inflation. That remains one of the key questions in Big Bang cosmology, Filippenko said. Big bounce. Most cosmologists regard inflation as the leading theory for explaining the universe's characteristics, specifically, why it's relatively flat and homogeneous, with roughly the same amount of stuff spread out equally in all directions. Various lines of evidence point toward inflation being a reality, said theoretical physicist Andy Albrecht of the University of California, Davis. They all hang together pretty nicely with the inflationary picture, said Albrecht, one of the architects of inflation theory. Inflation has done incredibly well. However, inflation is not the only idea out there that tries to explain the universe's structure. Theorists have come up with another one, called the cyclic model, which is based on an earlier concept called the eukaryotic universe. This idea holds that our universe didn't emerge from a single point, or anything like it. Rather, it bounced into expansion, at a much more sedate pace than the inflation theory predicts, from a pre-existing universe that had been contracting. If this theory is correct, our universe has likely undergone an endless succession of bangs and crunches. The beginning of our universe would have been nice and finite, said Bert Overroot of the University of Pennsylvania, one of the originators of eukaryotic theory. The cyclic model posits that our universe consists of 11 dimensions, only 4 of which we can observe, 3 of space and 1 of time. Our 4-dimensional part of the universe is called a brane, short for membrane. There could be other branes lurking out there in 11-dimensional space, the idea goes. A collision between 2 branes could have jolted the universe from contraction to expansion, spurring the Big Bang we see evidence of today. The universe we know takes shape, but first, how did our universe spring up out of nothing? Cosmologists suspect that the four forces that rule the universe, gravity, electromagnetism and the weak and strong nuclear forces, were unified into a single force at the universe's birth, squashed together because of the extreme temperatures and densities involved. But things changed as the universe expanded and cooled. Around the time of inflation, the strong force likely separated out. And by about 10 trillionths of a second after the Big Bang, the electromagnetic and weak forces became distinct, too.
Well guys, this video is over. I hope you enjoy, and if you enjoy, be sure to hit the like button. If this video reach 500 views, I make part 2 of this video. So share with your friend. And until the next video, have a great time.